how old is the Earth? Is it only a few thousand years old, as some believe from a literal reading of the Bible? Or is it roughly 4.5 billion years old, as mainstream science says? This question shapes how we see our world, history, and even faith. Today we'll lay out both sides fairly. The strongest evidence, honest challenges, and the mysteries that remain, so you can decide for yourself. Welcome to Origins Lost, where we investigate what the world forgot and what it still debates today. Let's start with the young Earth view. Many Christians read Genesis as a literal record of Earth's history. By adding up genealogies, some scholars, like Archbishop Usher, dated creation around 4004 BC. That places Earth's age at about 6,000 years. One core argument is the idea of a global flood, Noah's flood, as a real worldwide catastrophe. Young Earth creationists say this explains major geological features such as massive fossil graveyards, thick sedimentary rock layers, and even large coal and oil deposits. They often point to the Grand Canyon as an example of rapid water erosion, not slow carving over millions of years. Another big point is radiometric dating. Creationists argue these methods rely on assumptions, like constant decay rates in closed systems, which, if wrong, could produce ages far older than reality. They also highlight that carbon-14, which decays relatively quickly, has been found in coal, diamonds, and fossils said to be millions of years old. Some evidence comes from unusual finds like soft tissue and dinosaur bones. Flexible blood vessels and proteins have been discovered inside fossils that should be 65 million years old. Young Earth scientists ask how such material could survive that long. They also point to Earth's magnetic field, which is decaying at about 5% per century. If you rewind that decay, they say the field would have been impossibly strong, just tens of thousands of years ago, suggesting a much younger planet. Supporters also mention ocean salinity. Rivers wash salt into the sea every year, yet the oceans aren't nearly salty enough if Earth's oceans were billions of years old at today's rate. Another clue they point to is polystrate fossils. Fossilized trees standing upright through multiple rock layers. To them, this shows that sediments can build up quickly, not just slowly over vast ages. Some creationists also argue that helium trapped in zircon crystals points to much faster radioactive decay in the past, which would shorten Earth's age dramatically. They also question the timeline of human population growth. If modern humans have lived for hundreds of thousands of years, they argue we'd expect far more people in the ground and in the fossil record. Finally, a few point to the number of visible supernova remnants, claiming there are fewer old remnants in our galaxy than there should be if the universe is billions of years old. Taken together, these clues shape a picture of a young Earth, created by God just thousands of years ago, and shaped by a single global flood. Now let's see why most mainstream scientists say Earth is about 4.5 billion years old. First, they point to radiometric dating. Elements like uranium decay into lead at fixed, measurable rates. Earth rocks, moon rocks, and meteorites all date to about 4.5 billion years old. Some of Earth's oldest minerals, tiny zircon crystals, reach back 4.4 billion years. Second, the fossil record shows a clear pattern. Rock layers stack in a predictable order. Simple sea life at the bottom, then fish, amphibians, reptiles, mammals, and finally humans. This progression supports the idea that life developed gradually over hundreds of millions of years. Another strong line of evidence is ice cores. Scientists drill deep into Greenland and Antarctica, pulling up cylinders of ice that contain distinct layers, one for each year of snowfall. Some cores have over 800,000 layers, which line up with known volcanic eruptions dated by other methods. Then there's the record in ancient trees. Bristlecone pines have over 5,000 rings. By matching overlapping ring patterns from living trees and ancient preserved wood, researchers extend that timeline back more than 11,000 years. Plate tectonics offer more clues. The continents are still drifting today. For example, the Atlantic Ocean widens by about an inch every year. Given its current width, scientists calculate that it took millions of years to open. Another piece of evidence is distant starlight. We see galaxies that are millions, even billions, of light years away. Since light travels at a known speed, it must have taken millions or billions of years to reach us. These findings are cross-checked by using multiple radiometric methods. Different elements, like uranium-lead, potassium-argon, and rubidium-strontium, all produce consistent ages when used on the same rocks. Finally, physics supports an ancient Earth, Earth's internal heat, the life cycle of the Sun, and the heavily cratered surface of the Moon all fit a timeline that spans billions of years. Together, this evidence paints a picture of an ancient Earth and an ancient universe, shaped by slow processes over vast spans of time. Of course, both sides have rebuttals. Young Earth creationists argue that radiometric dating relies on assumptions about starting conditions, decay rates, and closed systems, which they say can't be fully proven. They argue that the flood explains the fossil record's order: sea creatures buried first, then amphibians, then land animals as floodwaters rose. To answer the distant starlight problem, some say God created light already on its way, or that the speed of light was once faster. But this idea is hard to test because it can't be directly observed today. As for decay rates, mainstream scientists counter that they have been tested under extreme conditions and stay constant. They say the fossil record shows clear, ordered layers match gradual evolution, not chaotic flood burial. Polystrate fossils are explained by local rapid burial. For example, volcanic eruptions or underwater mudslides, not a worldwide flood. Then there's the soft tissue found in fossils. This is explained by unusual chemical conditions or bacterial biofilms that preserve it longer, not because the fossils are young. For helium and zircons, geologists say the leak rates align with deep time when measured properly. As for the speed of light, physicists point out that changing light speed would break other physical laws we see working today, and the count of visible supernova remnants matches predictions since older ones fade or blend with space over time. Even with strong evidence on both sides, some questions stay open. These mystery boxes keep the conversation interesting. For the young Earth view, distant starlight remains a big challenge. If the universe is only 6,000 years old, how did light travel billions of light years? The idea of light created in transit explains it theologically, but breaks known physics laws. Deep ice cores are another puzzle. Hundreds of thousands of layers, each matching annual snowfall and volcanic ash events, are tough to squeeze into a few thousand years. The consistency of radiometric dating across different elements is also a major test for the young Earth view. Then again, on the old Earth side, the survival of soft tissue and dinosaur fossils poses a real problem. While paleontologists say the bones are ancient, the preservation process still isn't fully understood. Large rapid formations, like canyons carved in days by the Mount St. Helens eruption, remind us that not all change is slow. And then there's the human record. If modern humans have been here for 200,000 years, Why does written history only cover about the last 5,000? Archaeologists say early people lived in small nomadic groups, but some still find the long gap before written history curious and open to debate. So, is Earth young or old? Both sides present evidence, faith, and different assumptions about how to interpret what we see. The questions we ask and how we answer them shape our understanding of who we are, where we came from, and where we're going. What do you think? Which arguments make the most sense to you? If you'd like to go deeper, we've linked a helpful book in the description below. This is an Amazon affiliate link. If you buy through it, we may earn a small commission at no extra cost to you. It helps support this channel and lets us keep exploring big questions. We're also putting together The Vault, a subscriber-only corner where you'll find extra research, timelines, and evidence connected to debates like this one. Watch for updates soon. Thanks for watching. As always, drop your thoughts in the comments, hit subscribe, and stay curious.